Hello, I am Brandon Aydlett, the Science and Operations Officer here at the National Weather Service office in Guam. While I'm sad not to be able to attend this conference in person, still want to tell you a little bit about how we use the direct broadcast satellite applications across the National Weather Service Pacific region. But first, let me give you a quick introduction to the National Weather Service region. We consist of a number of offices in the eastern, the western hemisphere, and also the southern hemisphere, with American Samoa down there, well south of Hawaii. We also have the Pacific Region headquarters there in Honolulu, Hawaii, where we also have WFO Honolulu, the Central Pacific Hurricane Center, the Pacific Tsunami Warning Center, all co-located right there in Honolulu. And the Western Pacific Weather Forecast Office, Guam, is situated right in the southern tip of the Mariana Islands. And then we have a number of Weather Service offices across Micronesia, from the Republic of Palau, across the Federated States of Micronesia, in Yap State, Chuuk State, Pohnpei, and then also in the Republic of the Marshall Islands, there in Majuro. Now, we have a number of satellite systems across the Pacific. We have very few radars, especially in the Western Pacific, where Guam has the one lone weather radar. There is one on the Army base in Kwajalein, Marshall Islands, but only the Guam radar is what we receive in AWIPS. We have a number of LX band receivers across the Pacific, one here at Guam. There are a couple across Hawaii, and then there's one at the Army base in Kwajalein. Primarily, our satellite imagery comes from the geostationary satellites for the West Pacific, Himawari 8. We have our own receiver in the backyard of the weather office. And then there is also a Himawari receiver and also a Goes West receiver in Hawaii. Here at the Ford Island Pearl Harbor, we see the rooftop of the Inouye Regional Center. Himawari cast is received there on site, as well as the Goes West system, and then of course also the LX band receiver up on the rooftop. Here at Guam, we had our LX band receiver installed back in 2018, I believe, and there you see the installation there in progress in the middle picture. And now the dome sits just like that in the far right picture in our backyard. We also have our geostationary Himawari 8 receiver, and just about 10-15 yards away from the LX band receiver. I've looked at a couple of presentations, and I believe this slide probably comes from Liam Gumley. This shows the footprints of the direct broadcast receivers. Otherwise, if we did not have our own DB receiver in Guam, there would be quite a bit of latency in receiving the imagery from the polar satellites, waiting for the imagery, the data to come through the system, through the U.S. and then get transmitted to Guam. But having our own system in the backyard is proven quite beneficial. So some of the supported satellites by our DB receiver: NOAA 20, Suomi NPP, Terra Aqua, METOP B. METOP A used to be received by our system until it was retired. And then, of course, the GCOM. There's a number of different imagers and sounders that are quite beneficial to our operations as forecasters, giving us a lot more insight into the status of the atmosphere, looking at moisture profiles, temperature profiles, assessing instability, and all these different sensors provide a lot more insight into our forecasting and the state of the atmosphere. So looking at our AWIPS here at Guam, we see our LX band receiver is down into the local sat, and then you can see in the middle and the far right drop-down menus just a large assortment of some of the data that we have at our fingertips. Some of the benefits to the Weather Service: well, one is we have a significantly improved spatial resolution, with some of the spatial resolutions getting as improved as 375 meters for the visible and near IR, with some of the satellites also getting a resolution as high as 250 meters. There's a number of geophysical products that are produced from sea surface temperatures, clouds, rain rates, which is very important across our region, especially in Micronesia. and of course for the tropical cyclones, but also looking at the temperature and moisture across the region. Some of the new the really nice features are the day and night imaging with the dynamic day-night band that has been quite useful, especially with some of the typhoons passing through the Marianas. Another one that's very important with our tropical cyclones is the microwave imagery for better assessing the center positions of developing tropical cyclones. Out here across the Pacific, tropical cyclones are the more notorious severe weather features, and with the many tropical cyclones developing across our area of responsibility, it's critical that we know exactly where the centers of these developing circulations, depressions are, and that helps us lead to where they're going to be moving. It helps us to also understand better what the status of the convection, where the convection is with regards to the center of the circulation. But there is one pitfall, and that is it's actually an improvement, is the lowered latency of the DB imagery. The pitfall is with fewer satellites orbiting, that we don't get too many refreshings of the imagery. But with the lowered latency, having that data be received by our backyard receiver, it's processed in our building and then in our computers within 10 to 15 minutes. So that is a significant improvement over waiting for more than an hour to get it through other methods. So there's a number of applications in how we use this data in our systems and our decision making. And so I want to talk to you just about a couple of those. One is through the tropical cyclone assessment. So these are actually from the NRL webpage, from some typhoons, notorious typhoons that have struck the Marianas in the past 4 to 5 years. One on the left is Super Typhoon U2, and you can see a very well-developed eye as this storm is approaching the Marianas. This was a significant typhoon, Category 5, as it just blasted through Tinian and Saipan, just 100 miles north of Guam. This microwave imagery is critical for assessing where the eye wall features are. It helps us give a better heads up to the islands as they are about to face the onslaught of the eye wall convection and just the tremendous torrential downpours and significantly strong winds. On the right is another image. This is Typhoon Pseudolore back in 2015. This was a really small system, at least the inner core of the typhoon. While we expected about a Category 1 typhoon, there is a very small core, pinhole eye, that crossed over Saipan, delivering about Category 3, Category 4 damage. And this was a very small feature that was even hard to resolve within the microwave imagery. Additionally, like I said earlier, the microwave imagery really helps in identifying the center positions of tropical cyclones. Most tropical cyclones are developing within the Micronesia region, down to the south or even southeast of Guam. And so while there's usually this dense overcast over the centers, it's the microwave imagery that really gives us that insight into the inner core of a developing circulation. For Hawaii, this was Tropical Storm Flossie back in 2013. You can see the geostationary satellite on the far left. It was much worse spatial resolution than the current goes west. So you can actually see very well in the center in the right picture, the VIIRS, much higher resolution than the VIIRS imagery. And then, of course, the day-night band. In the nighttime picture, it was very hard to depict the center of the circulation, especially in a lower resolution IR. But with the day-night band, higher resolution from the VIIRS, and especially with a brightly lit moonlight, it's much easier to see where that center of circulation is. Here's another picture from the VIIRS NOAA 20 of Super Typhoon U2 passing right over Tinian. This was a perfect timing of the satellite pass to see Tinian right there within the center of the eye. Saipan just to the north is partly is straddling the eye wall. Only the very southern 1 mile of Saipan managed to get into the eye. And when we were talking to people on the phone during the passage of Super Typhoon Yutu, we're looking at the Himawari 8 satellite imagery. And so there's a little bit of parallax, but with the lower resolution of the Himawari 8, it was hard to tell whether the southern half of Saipan was in the clear within the eye wall or not. But as we were taking phone calls, we're talking to people near the airport, which is in the southern tip of Saipan, and they said they never got out of the worst of the eye. It was just the winds were howling and structures were just collapsing, lots of debris blowing around, and so there's that stadium effect of the eye that it was just hard to really resolve in the geostationary satellite. But with the higher resolution of the polar orbiter from NOAA 20, we were able to get a better insight onto just really where that eye wall was located. Additionally, in 2018, Typhoon Mangkhut kind of passed through the Marianas. It delivered a strong blow to Rota. That is the northern circle, the northern yellow circle. Saipan and Tinian are very bright up to the far north of both images. And then Guam is in the southern tip of both images. Before and after, you can see on Guam a lot of lights around the southern perimeter road, and then of course on the western tip of Rota. After Mangkhut's passage, Guam had a lot of rainfall. The stronger winds, of course, were at Rota, and you can see where there was significantly reduced lighting from the power outages across both islands. For the non-named storms, we do get some strong to almost severe thunderstorms across the Pacific. I've not really witnessed anything that has truly met the criterion of 60 mile per hour winds for a severe thunderstorm, but we have certainly been close. And there's been some rare occasions, maybe once per year, where we see some really strong thunderstorms that produce a lot of lightning. Such was the case in September of 2019. We had a typhoon up to the northwest of the Marianas. We had 70 knot northeast winds aloft over the area, so you can kind of see that wind shear in effect with that battering northeasterly wind shear. And then we had southwesterly winds at the surface, a bit of a weak monsoon flow. So we had all these thunderstorms across the Marianas, up near Tinian, Saipan, east of Rota and Guam, and they were holding fairly stationary, kind of being driven by the upper level shear. The Himawari 8 imagery, you can see those cold cloud tops, but it is with the VIIRS, the adaptive day-night band, that you could really see where those overshooting cloud tops were. You can see the shadow in the moonlight, and really depicting those cloud top features that greatly correlate with the heavier cores and the weather radar. Another view, looking in the center picture, you're seeing all the lightning reports. This is the 1 hour lightning, I believe. But in my 12 years here on Guam, I have not seen a lightning being produced like these storms did. And so it was a very impressive evening. Fortunately, most of these thunderstorms stayed just offshore of both Tinian and Saipan, though another resurgence kind of developed in the early morning hours, delivering quite a few rumbles of thunder, waking everybody up. We have a lot of heavy rainfall. Kosrae and Pohnpei in Micronesia are two of the wettest places on the planet, getting anywhere from 200 to 400 inches of rain. There's a little bit of topographic, orographic effects. There's just a very wet jungle all the time, but it's very critical for us as forecasters to know where that loaded moisture is situated, especially within the intertropical convergence zone, but also when looking at the widespread convection on the infrared imagery, where exactly are the heavier rainfall cores? We see a lot of heavy convection passing over the islands, And then when we look at the rainfall observations, is very little rainfall. And the difference is, where is that heavy rain shaft falling? And sometimes it's just missing the rain gauge by a few miles. So we're looking at some of the microwave imagery, just really depicting where some of the heavier rainfall cores are. We've not delved too deeply in some of the higher frequencies, the 157 gigahertz, 190 gigahertz, but we're still kind of looking at them, assessing them, how we can gain better insight into the convective features within our region. But what we really do enjoy is the precipitable water products provided by the MIRS sounder. We look at the SIMS Mimic TPW product online and also within our AWIPS. It just gives a lot more insight on where the moisture is passing through the area. Sometimes as you see a heavy moisture loading, there's not much convection until you've got some type of triggering feature that then all of a sudden you've got this onslaught of moisture and rainfall. So looking at the computer models, we like to look at the 24-hour rainfall outlooks, and so we have the 24-hour QPF. Here I've got several different models displayed: GFS in the top left, European on the top right, National Blend model on the bottom left, and then the NavGem on the bottom right. I've kind of tweaked the color scale just to really highlight some of the heavier rainfalls. The GFS tends to be a little bit more bullish on heavier rainfall events, seeming like it really likes to pick up on the mesoscale features. And so we look for these heavy rainfall areas and then try to better assess it through the satellite data. But looking at the 24-hour rainfall amounts, especially exceeding 3 to 4 inches, that tends to equate to some problems with localized flooding in some of the streams and creeks across the islands. And so we like to get a heads up on these situations. So here's a similar case for across Micronesia, Chuuk and Pohnpei in the center. So we're looking at infrared, the clean IR from Himawari 8, and we see a lot of cloud cover, but where exactly is the heavy rain? Of course, animating this imagery will really help a lot, but if you're taking a freeze frame moment, where exactly is the heaviest rainfall? And that's where the microwave imagery can really come in handy. I'm not sure. I think on this top left, the rain rate from this image, from this satellite pass, I've never seen it quite that high. So I suspect it may have, could be some of the estimation might be a little bit too high, but it really does depict very well where some of those heavier rainfall cores are. You see that in the 165 gigahertz imagery on the top right. And sure enough, a little bit later, when we got the 24-hour rainfall reports from both Chuuk and Pohnpei, we're seeing in excess of 2 inches in 24 hours. And a further look through the observations showed that much of that rainfall fell at both locations within a 3 to 4 hour period. So receiving that much rain in that quick of a time would have some impacts for the islands and the people. For Hawaii, they do have some rain effects. The Big Island is notorious for the windward side. Widespread rain. They're always wet. They're always cloudy. And so it's very important for the forecasters in Honolulu to get a better understanding of just where that moisture is. A lot of times the upper level features kind of trains the thick cirrus over the Hawaiian Islands, and that obscures the satellite view, especially the geostationary satellite view of where the convective clouds are. That's where the microwave imagery really comes in handy, finding out where that moisture is, how it's moving, and where it may be lining up to provide some major orographic rainfall. We also have quite a few volcanoes and wildfires across the Marianas. The whole Mariana chain is full of volcanoes, and then also the Japanese islands farther to the north. Here is a case of a volcano that was well north of the Marianas, Nishinoshima. This one erupted a couple of years ago, and the looping image to the left, that is the Himari 8 shortwave infrared, 3.89 microns. And you can see a small little red dot indicating the hot spot of the volcano. There's actually a couple of dots. There's some other features going on. And then, of course, in the VIIRS, dynamic day-night band, you see a bright spot right there in the center of the image. That is the volcano. And sure enough, as we did a little bit more research, trying to find some active volcanoes, there's a number of web pages that were highlighting this volcano as it was actively expanding its island size. Closer to the Marianas, and actually within the Marianas, Pagan Island was erupting for, well, maybe not erupting, but it was certainly belching for a while, spewing off quite a bit of volcanic ash and some clouds for several weeks a couple years back. And so this is the MODIS True Color RGB. Really pinpoints the discoloration of the clouds and the ash and the fog coming out of Pagan. It's significantly different from the trade wind cloudiness in the background. And the 4-panel to the right, we've got the Himari 8 fire temperature RGB. Top left, the Himari shortwave IR, and then the red visible in the bottom left, and then the VIIRS shortwave IR that really highlights that the volcanic clouds, the ash, and the smog, and that red plume. Of course, with the wildfires, we do see a number of wildfires across central southern Guam, especially in the dry season, which is generally ranging between January and June every year. Sometimes that fire season can be very active, especially following an El Nino when we have a pronounced drought season. And so we see some pretty large wildfires across the southern mountains, especially with the trade winds picking up, especially when they get into the 15 to 20 knot range, as they often do in the dry season. Here's a number of different wildfires across the southern part of Guam. One is deep within the mountains, hard to access, and sometimes the fire services just have to allow these fires to burn themselves out as they reach either creeks or the ridge tops. But the fire services will be watching these events very closely as they encroach on habited areas, the villages, to keep the fires at bay and not affect the residents. Another fire in a very far southern tip of Guam. So the VIIRS imagery is extremely useful in pinpointing these fires. We often use the Doppler radar imagery to pick up on wildfires with the standing plume of convection. That's how it looks. But when our radar is inoperable, as it has been a lot the past couple years, this is where the satellite imagery is key for identifying these features. Same thing for Saipan up to the north. You see these hot spots in all the different imageries. And sure enough, they had a very large wildfire at this point. Our radar on Guam will not see this. It is pointing about 15,000 feet above Saipan by the time that lowest radar beam gets up there. Finally, we have a lot of NUCAPS imagery that is critical. We have only 6 upper air sites across our region, from Guam to Palau to the Marshall Islands. So receiving NUCAPS profiles is absolutely critical to get a better understanding of the atmosphere and the moisture profile. This was a recent case to the east of the Marianas. We saw some low-level cloudiness, not really precipitating, but then there was an upper-level low spinning off just to the northwest of the clouds, and we saw all these altocumulus, lower-level cirrus clouds forming, and so our first thought was there's got to be an unstable layer, and when we looked at the nearest NUCAPS profile, we definitely see there is a increased instability capped off by an increased stability in the higher levels. And when we look at the corresponding NASA Sport gridded NUCAPS, you definitely see in the 700 to 500 millibar level, there's steeper lapse rates with that increased instability. And then in the 400 to 200 millibar level, there's increasing stability with those shallower and lessening lapse rates. Across Micronesia, we like to diagnose and use the NUCAPS profiles to better get a improved understanding on where the moisture is. Here near Pohnpei, we were concerned about the increasing showers, and at least in the next 12 hours after this forecast period. But looking at the NUCAPS profiles near and also to the east, we see a very shallow moist layer capped off by a much drier layer, subsidence layer above that. And this would be typical of a dry season pattern that's just not very productive for rainfall. Meanwhile, we have shear lines across the tropical Pacific, extending from Wake Island as the cold front passes off north of 20 North, and it extends down into the Mariana Islands. There is a little bit of air mass modification, but the air mass is usually quite dry above 10,000 feet. And so as we look at the NUCAPS profiles, we certainly see that reflected with a very low level, shallow moist layer with much drier air aloft. Closer to the Marianas, we see a little bit of change in the atmosphere to the west of the Mariana Islands. We see a little bit of deeper moisture, so there's some type of feature that's pushing that moisture into the 10 to 12, 13,000 foot level of the atmosphere, perhaps more capable of heavier showers versus farther to the north and east. Still that shallow, moist layer capped by dry subsidence air above 7,000 feet, just not capable of producing much rainfall. Sometimes the mesoscale models have a difficulty forecasting these events, getting a little bit too overwhelming with the precipitation forecast, maybe even forecasting thunderstorms that just would not be likely in this type of a profile. Now there's sometimes we see some stuff on the night shift, as we saw in this case. We're looking at the VIIRS dynamic day-night band. One night, my coworker and I, we were just looking at the latest feed coming in, and we see this bright spot off the southwestern tip of Japan, and we thought maybe there's just some type of anomaly in the satellite image or something. The next image, though, was dark. And so as we looked at it a little bit closer, we'll go back to the prior slide, which doesn't let me. As we looked at between the two slides, we noticed it was actually a true light. It was reflecting off the surrounding cloud cover. So it wasn't something anomalous with the satellite, but the satellite actually observed something. So as we looked at the corresponding shortwave IR, we see this hot spot showing up very clear. And as we started digging around and we consulted the almighty Google, we came across there was a Japanese rocket launch. And so sure enough, this rocket launch was captured by the VIIRS imager, and we saw that bright spot. Another curiosity that we see across the islands is these hot spots that seem to, they look like wildfires. And as we dig deeper, and we actually come across that there is a solar farm in that part of Guam, that the shortwave satellite imager is actually seeing the shortwave radiation from the sun reflected off the solar panels. The solar farm is a few dozen acres in size, so it's pretty massive, and it's just enough to show up on the satellite image. There's actually another solar farm I did not know about farther up on the eastern coast of Guam. Did not know about it until for a while we're seeing these hot spots in the VIIRS imagery, and it's like that's not an area prone to wildfires. And sure enough, later on we found out there was a massive solar farm being installed there. But with that, I will wrap up my portion of the conference. If you have any questions, feel free to send me an email, william.aydlett. William is my first name, but I go by Brandon. Send me an email, and I'd be more than happy to have some discussions with you. Again, I look forward to meeting some of you through email in the near future, and I look forward to seeing some of what you're presenting later on in this conference. Take care.